Hello all, Lorcan here. I'm going to be doing a tutorial on basic touch inputs for the Android and using Unity's Navmesh system. So this is the system Unity uses to have their AIs and player characters able to navigate the scene without bumping into obstacles or walking off edges. So here is the finished version of the scene, and I'm going to play it now. And you will see the red line is where I'm touching the screen on my Android. And you'll see that the player character is navigating the scene in order to reach this destination. So I'm now going to go to the plane scene I've got, which hopefully will be on the learning space. Okay, so first I'll just add in the basic scene object. So there's my environment, there's my robot, who is the little character I'll be using. And I'm just going to reposition the camera, go to game, objects, and align with view, and there we go, reset my camera to be in a nicer perspective. So setting up the nav mesh in Unity is actually quite simple. So I'll first set up the actual area, and to that I need to select the area I want to be walkable, so that'll be this ground mesh I've made, and set it to be a static game object. What static means is when I actually play the game, this object won't be able to move or be changed, but we can do a bunch of things on it for pre-rendering things. That will be light maps, and that will be the nav mesh we're about to do. So to access the nav mesh options, you go into your window, you go to navigation, it's up here. These are the settings which we'll go into more detail at the end of this, but for now we just simply click bake, and you have to save the scene before you can bake things. And there we go, so that's the nav mesh it's made automatically. I'd like the character to be able to go a little bit closer to the wall, so I'm just going to change the radius here, 2.5, and you'll see the little visual there gives you an idea of what kind of range your character can do. So I'll bake this again, and there we go. So that's the nav mesh sorted, so we can now get on with getting the character to work. So I'm just going to select the character I've got here, go back to the inspector, and I want to add the component from navigation, nav mesh agent. And I'm going to reduce his radius here. So the nav mesh agent is the actual script that manages where the character goes on the nav mesh, how he goes around, the speed he'll go at, sort of rotation, all the things you see here. It's a very powerful tool which I recommend you look up on the Unity reference later. For now, I'll just go for the very basics of setting a destination. So for that, we are going to make a script, and we're going to place it on the player character here. Let me open up mono development. All we want is we want to set up, first we need to get something to actually access the nav agent. So actually before that we need to go to using Unity. You see at the top it's got these systems that we're getting. We need to add into this along with Unity Engine using Unity Engine AI, and that will allow us access to the nav agent components. Now if I type nav mesh agent, I will actually have it pop up. I'll be able to call it that. Just to show you what happens if I don't have Unity Engine, so if I comment that out, nav mesh agent will return as an error because it doesn't know what that is until we actually give it the reference to that. And the second thing I want to add in is a public vector3, so that's a position. That'll be the target. What serialized field means, for those of you that don't know, is what I don't need on this public variable, and actually I'll get rid of it. For private variables, it lets you see them in the inspector. So if I save this now and go to the inspector, you'll see I've got the nav agent there and the target position. If I just quickly go and delete that from the script, you'll see that the option to add the nav agent has disappeared. So that's why you have serialized field. It's just very useful for that kind of thing. So actually setting up the nav agent to actually go somewhere is very simple. All I do is I reference the nav agent component here, agent, set destination, and I want it to go to whatever the target vector is. So I'm just going to add in an extra function here, debug.drawArray. So this is going to draw a line. I'll be discussing what ways are later on in this, but for now I want it to be at the position of the player character, so transform.position. I want it to be pointing upwards, just vector up, which just is the basic up value of the world, and I'll choose the color red. Alright, now before I play, I think before I play, something I need to do is I need to go to the project settings, I need to go to editor, and I'm using Unity Remote 5. That's an app on the Android that lets me actually prototype by plugging in my phone and USB real-time back and forth between the game engine and my phone, so I can see debug messages and all that stuff. The only thing I need to do is set Unity Remote Device to any Android device, and I'll be able to see this. So I just go to Simple Web, I'm going to assign the Navmesh agent here, and when I play the game, there we go, I need to turn on gizmos. Here we are. So now if I go here, and you'll see as I sort of move around the X value, actually move around, and actually I've just realized in the script I want this to be not the transform position, that's my fault there. I want it to be agent.destination. This would be more useful. So I've got to switch to the monitor to change transform position to agent.destination, and I'll restart this. So that now the X is actually where the player is aiming to go. So you see the red line. What set destination does is it will place the transform the closest valid place on the Navmesh. So that's why it's changing its height, is it's actually finding the best position it can there. So if I change this, it should go, if I increase the Y, there we go, now it goes up the steps. So that's the very basics of the Navmesh agent. Now, obviously we want to be able to go a bit fancier than that. We want to be able to touch the screen and set where it goes. So for that we need to actually be able to get touch inputs and get from the touching position on the screen somewhere in the world space. That's what we'll be covering now. So I'm going to make a new script, player inputs, I'll ignore the capital L there. And I'm just going to clean up my scene a little bit to make everything easier to manage. So I'm going to make a empty object, player systems. You don't have to do this bit, I just find it makes things easier to manage down the line. I'm going to put the main camera in there. Put the scene objects as well. And I'll put player inputs on the player system. So for this script, we're going to get touch inputs from where you actually touch the screen. We're going to use that to cast a ray, and rays are essentially just, think in first-person shooters, when you're aiming the gun to something, you press the trigger button, it will send out a ray, which is just a straight line, to see what you hit and then apply damage to that. So that's what we'll be using, except for we'll be using it to find out where the ground is that we want to set as the target destination for our Navmesh. So to do that, I don't need any start functions. What I really need is a reference to the script we just made. So the first thing we're going to do is we're going to use inputs to actually check if there's any touches happening. So input.touches.length. And if it's more than 0. So touches is the general reference to any of the touch inputs you do on the Android, because of course there could be more than one, will be stored in touches, and we're just getting how many there are and checking that any are happening before we bother doing any more of these scripts. And after that, if we've confirmed yet there's a touch happening, we're going to go input, get touch, which is like get button, going to refer to the first touch that's actually happened so far, so that's 0, and we want to get its phase, and that is the phases would be the state of the touch. That'd be, so you've got the options of begins, that'd be when your finger goes actually down on the screen, when it's moving, stationary, or ended and cancel. So for what we're doing here, we want ended. So when the finger goes off the screen, that is when it's actually going to check all these other things. So I'll actually just put a debug here. And if I go back into Unity and I open up the console, there you go. So you'll see it's giving me messages here whenever I touch the screen. So that's the basic of actually getting a touch input. Now we're going to use that to make a ray cast. So I'm going to make a ray. I'm going to call it the touch ray. And I'm going to use a function called camera that's inside of the main camera in the Unity scene. So these two camera.main just gets the main camera in the scene that's being used. And I want to get screen point to ray. So this is something Unity's made specifically for this kind of thing, just getting a 2D position on the screen and making a ray cast from the camera. And I wanted to do input again, get touch again, and I want to get the same touch that we would have actually triggered this event here. And what you can do here is you can actually get the position of the touch on the screen. And now if I actually add a debug below, debug.drawWay, if I go back into the Unity scene, oh, I forgot to set the time on that. When you're doing some of these debugs, you have extra commands that will pop up, so I'm going to make the way just stay around for a few seconds. Here we go. So the blue line you see is the raycast that's being shot out whenever I touch the screen based on where I touch it. So you can actually begin to see that now. And we are going to use this to get the position on this ground mesh here to set the nav agent to actually go to. So to do this, we add a, whenever you do a raycast function, so I'll actually start that now, if raycast is in physics.raycast, and we've made the ray already with touch ray, so usually you might want to have a origin point and a direction. Touch ray is both of those combined, so we don't need to bother with that. And the next bit you'll need will be a out, so that means I need to make a raycast hit, just call it hit for now. And what the raycast hit does is that's essentially something we can store the information from the raycast into. So just to show it, so I'm just going to actually script this here. So vector3 new positions. This is the position we want to set the nav agent to go to. And if I go hit.point, that's actually going to be where the raycast hits in the game world. It will return it to new position. And if I go into the player script and I set the target to be the new position, or new pos, oh, there's actually an error. Let me check what that is. Oh, I forgot to just put the add there. Now, before I start, this should not work because there's one thing I've actually not done yet, which is I've not made the mesh collider for this object. So I'm just going to go to, I'll do it from the menu. I need to go to physics, mesh collider, while selecting the ground area, and there we go, automatically set that up for me. So now when I click somewhere on the screen, and I've also actually forgotten to put the reference into the input scripts, there we go. Now when I tap somewhere on the screen, you'll see the red debug line appears where I've tapped. You can see the blue wave there. And the player will move to where I aim towards. In the full version of this project, I would have added a few extra debug things to the script, but what you see in this window here is all you really need to actually get the basics of this to work. So before I wrap this up, I'm going to be doing two more things. I'm going to make a script so that the camera actually follows the player in a smooth manner. So it'll be a very basic camera script. And I'll also go over just some of the extra features of the nav meshes in Unity. So I'm going to make a new script. And I'm going to make a empty object. I'm going to just select. So I'm going to put the camera script into this empty game object here. I'll actually make the empty visible here as this blue dot, just so I don't have to bother with the angles or setting anything. So I can keep the script quite simple. So this is going to be one of the more simple scripts you can actually do if you're going to stick with the basic system. Your camera systems will probably want to be more complex most of the time to allow for some better control of rotation and the like, but this one just simply is going to track the player. So I'm going to get a reference to the player's transform so I can get their position, and I'm going to include a float value which I can use to set how fast the camera will actually follow the player, and I'll set that to be a default of, I found 2.5 seems to be a good one, so at the F at the end. And all I need to do is transform dot position to set the position of this object to vector alert. What vector alerts are is they get two vector points, two positions, and they will, every frame, sort of slowly, they'll go in between the two. So if I would set this to, I actually have my values in here, so transform dot positions, that's the position of the camera object, and the position of the target object, which would be the player. If I set this to be 0.5, then it would give me the return of somewhere halfway between this object and the player object, and it would do that each frame until eventually it was in the same spot. What I'm going to do is I'm going to make it the drag speed. I'm going to multiply that by time.delta time. You're going to see time.delta time in a lot of the examples you'll find online. The reason people do that is it keeps things consistent across frame rates. Essentially, figures out how much time has passed between each frame, and you can use that to make sure that if your game's running at 12 frames per second, the camera will still move the same distance as if the game was running at 24, 50 or whatever. So that's just a very useful thing to keep doing in your scripts. So I'm going to go back into the Unity editor. I'm going to set the player character as the target, and now when I play the game, there we go. So now the camera actually moves to follow. One little addition I'm going to do to the script, it's similar to the serialized field, is I'm going to add in a range value, and this is just quite useful for the programmers. So if there are values which you know you want to be between certain things, so I'm going to set this to be 1 and 5, it just changes it from that number to a slider, which is easier to edit and can limit it so that if you know there's something you don't want the designers to go beyond or under, as programmers you can actually set it so there's less chance of error. I'll just show, so if I put it to 5, it sticks to the player more closely. If I limit it all the way down to 1 though, you can see it lags behind a lot more. I usually want that in games just to kind of add a bit more feeling of movement there. So that's the basics of the Navmesh agent. With that, you should be able to do quite a bit. Of course, you need to look up more to be able to do more things, but this should be enough to get you started. So good luck, and I hope you will. If you have any questions, feel free to ask me or Dan when we're available.